like difficulty. So page 5 is actually the easiest. So for number 1AI, it asks you what 3A would be. What would you do for that one?
Forgot how to do this.
So it's just multiplying. So what we're doing is 3 times the vector 7, 1, 12, which means you just multiply each thing by 3. So this would be 21, 3, and 36. Not too bad, right?
Right.
Right. Okay. So I don't think I need to do every single one of those problems, but I will go skip down to 1. Oh my gosh. I give up. I'm going to start a new one. So 1DI, it says A plus B minus 2C. And then all you're doing is adding the same way you normally would. So we have 7, 1, 12 plus 5, negative 2, 3. And then we're going to subtract 2 times C. So that would be minus 2, 2, 4. So 7 plus 5 is 12, minus 2 is 10. 1 minus 2 would be negative 3. And then 12 plus 3 is 15, minus 4 is 9.
Sorry to interrupt, Ms. Thompson. Julia says that her laptop audio is acting up and she can't hear anything, and CG is trying to fix her Wi-Fi.
Sounds good. No matter what, it's going to be recorded, and they can post it. Tell Julia to try unmuting her computer.
Will do.
Thompson, sorry I'm late. I tried to enter into the wrong class. What page are we on?
Page 5.
Page 5, cool.
So really with when you're just multiplying and adding the way you normally would, it's nothing super fancy. But I'm going to skip down to number 3 since 2 is just the same thing that we just did. The only thing, actually, you'll see it in number 3. The only thing different from number 2 is you have to come up with the vector. So for A, when it says 4I, that means that it's the top number. 4, and then negative 2 and 1. Because these go I, J, K. Does that make sense? So I'm just taking the coefficient in front of the letters to make the vector. And that's vector A, and they want us to find vector B. So that it equals the 0 vector, and the 0 vector is just 0, 0, 0. It's just a really weird way of writing multiple equations. So what plus 4 would give us 0?
Negative 4.
And what plus negative 2 would give us 0?
2.
And what plus 1 would give us 0?
Negative 1.
And that's our answer. So that was 3A. Does anybody see anything else on that page 5 that seems super confusing?
Can you go over like 2A?
Yeah, sure.
Or one of them from 2?
Yeah. So let's say 2A, 1. So it's talking about, it says negative 5B, which means I have to figure out what B is. And it says B is I minus K. So the coefficient for I is 1. The coefficient for J, since there is no J, is 0. And the coefficient for K is negative 1. So that's B. And then it says to multiply it by 5. So that would be 5, 0, negative 5.
Okay, cool.
Can we do 3C?
Sure. So for 3C, it says A minus B would be J. And so we said that A was 4, -2, 1. And we're trying to figure out what plus 2 times BI, BJ, BK is equal to 3I. So 3I means there's a 3 in the first slot. And
Oh,
there's
no, I
no
meant
J.
3C.
Oh, I'm so sorry. It says J. My bad. So that would be minus. And it says J. So there's nothing in the I slot. There's 1 J and nothing in the K slot. So 4 minus something gives us 0. That something would be 4. -2 minus something gives us 1. That would be -3. And 1 minus something gives us 0. That something would be 1. So that's 3C.
Okay.
Okay. I'm going to move on to page 6 then. Welcome, CG. I'm glad you were able to figure it out. Okay, so for page 6, finding the magnitude, that's on your formula sheet. So for the magnitude, you're just taking it's basically the distance. And so you're taking the square root of each piece squared added together. So that would be for 1A, that would be the square root of 4 squared plus 2 squared, which is equal to the square root of 16 plus 4, which is equal to the square root of 20, which we can simplify to 2 root 5. All good? 2 is really not very different. It just has an extra number. So for 2A, we would have the square root of 4 squared plus 1 squared plus 2 squared, which would be the square root of 16 plus 1 plus 4, which is the square root of 21, which can't be simplified. So question 3 is the same thing. When it says distance, that's referring to the magnitude. The only thing is you have to come up with the vector. So whether you do AB or BA, in this case, distance is always positive. So it doesn't matter which one you do first, but I'm going to find AB, which you do that by doing B minus A. So we would have 3 minus 1 is 2, and 7 minus 2 is 5. So that's our vector AB. And if I wanted to find the magnitude of it, it would be square root of 2 squared plus 5 squared, which is the square root of 4 plus 25, which is the square root of 29, and that can't be simplified. Okay, and then from question 4, exact same thing as the one above it, except there is one more point. So does anybody have any question on that page?
Nope.
Okay. And then I'm going to move to page 7. So question 1 is calculating the angle between each pair of vectors, which you have that formula on your formula sheet. The formula is cosine theta equals V dot W divided by the magnitude of V times the magnitude of W. So yeah. It also gives you the formula for v dot w in case you don't remember. V dot w, there's two different ways you can do it, but the one that we would use in this case is v1 w1 plus v2 w2, so on and so forth. So for question 1a, we have 5, 1, 2, and 1, negative 2, 3. So for v dot w, we would get 5 times 1 plus 1 times negative 2 plus 2 times 3. And all of that would be divided by the magnitude of v, which is the first one, the magnitude of, so the square root of 5 squared plus 1 squared plus 2 squared times the square root of 1 squared plus negative 2 squared plus 3 squared. Make sure your negative 2 in your calculator is in parentheses, or if you're doing it in your head, just remember that it's going to be a positive number. So 5 minus 2 is 3 plus 6, we get 9 divided by the square root of 30 times the square root of 5 plus 9 is 14.
Would we need to simplify it, or could we just leave it like that?
If it's one without a calculator, simplifying it by hand as much as you possibly can. But if you have your calculator, then yes, just type it into your calculator. So it would be like 0.439. Okay. So really a lot of this is just using the formulas. I'm going to do question 3, part 2. Because question 2 is the same thing without a calculator, and so you just don't have to do the last step. Oh, I'm so sorry. Let me do the last step. So here, this is equal to cosine of theta, and since it was a calculator question, they wanted us to find the actual angle, so you would do the cosine inverse of the answer that you got. And it says in radians, so just make sure that your calculator is in radians. And you end up getting that theta is equal to 1.12. Sorry. Question 2, you just leave it in terms of cosine theta. So you would have been able to stop where we just stopped. For question 3, a lot of it is the same thing. The first thing is to find all of your vectors. So in this case, AB would be equal to 2, negative 2, 3, and BC would be equal to 3, 2, negative 7, and CA is equal to negative 5, 0, 4. From there, you use the formula that we just found, that we just used to find the angle of 2 of the vertices of the triangle. So I found cosine of ABC, and then you can find angle of cosine BCA. And once you find two of them, what do we know about the angles inside a triangle?
They have to add up to 180.
So then cosine of CBA would be equal to 180 minus these two answers. Make sense? Any questions about page 7? Okay. Page 8. Again, a lot of this is just using the formulas, but on your formula sheet, something that isn't there. Question 4 says determine whether each pair of vectors is perpendicular. So something that isn't on your formula sheet is that a perpendicular vector means that the scalar product would be equal to 0. This means if they're perpendicular, it means that v dot w equals 0. So in this case for 4a, you would have 2 times 1 plus 1 times -2 plus 3, -3 times 2, which is 2 plus -2 plus -6, which is -6. Is that 0? No. So then would this be perpendicular? No. All good?
Yep.
The next question on that page 1 is just using the formula for dot product, which is on your formula sheet. Question 2 is just using the equation for an angle between two vectors. So all of this is still just plug and chug.
Why does it say evaluate? That's just a really weird word in this one.
I mean, you'll see that word a lot probably on the IB exam. Instead of solve for.
Yeah, it just makes it seem a lot more complicated than it is.
Yeah, but it isn't.
Yeah.
Yeah. Okay. Page 9. I did 3, 1. This is again just using the formula. They just gave you a different piece of information. So it wants you to find in degrees the angle between C and D, which tells me I should be using the formula cosine theta equals v dot w over the magnitude of v times the magnitude of w. And they gave me most of the information. So it was just equal to 10 divided by 3 times 5, which is 10 divided by 15, which is 2/3, is equal to cosine theta. And then they ask for it in degrees. So make sure your mode of your calculator is in degrees. And then you would do the cosine inverse of 2/3, which ends up being 48.2 degrees when
On
round.
the IB exam, how often will we have to switch between degrees and radians?
Probably pretty often. A lot of your triangle questions will be in radians, especially on the non-calculator section, which I know doesn't apply to switching the mode in your calculator. But radians is easier to do in your head normally. But yeah, switching is going to happen pretty often. So all you have to do next to the second button on your calculator is mode. And then the third line says radian or degree.
Thank you.
You're welcome. Okay, also on this page, I highlighted 4B. It's a non-calculator question, and that's why I highlighted it. Again, it's using the same thing. They told you the angle is 60, so we're going to take the cosine of 60 degrees is equal to V, or A dot B, which they told us was 12, divided by the magnitude of V times the magnitude, or the magnitude of A times the magnitude of B, and they told us the magnitude of A is 8.
What number is this?
4B.
On page
9.
Okay, thanks.
Yeah, you're welcome. So cosine of 60, you should know it from your unit circle. Does anybody know what the cosine of 60 is?
One half.
Yes, 1/2 is equal to 12 divided by 8 magnitude of B. And then you just solve it like a normal equation. So you would get 4 times the magnitude of B is equal to 12. So the magnitude of B is equal to 3. Cool. Any other questions on that page?
Can you please go back for a second?
Yeah.
Thank you.
Also, number 5, I'll write down a couple of the things on the next page. A lot of them are air quotes common sense. So this one, for verify that, for number 5, you're just plugging things in and showing that it's true. But what these are called I think it's the algebraic properties of vectors, which a lot of it should just be common sense. But I'll go through a couple of things to make sure it makes sense. Are we all good with this page?
Mm-hmm.
Yes.
Yes.
Okay. So a couple of things that aren't on your formula sheet but are important to remember. A lot of them I think you'd be able to think through, but A dot B is the same thing as B dot A. And this makes sense because the formula for A dot B is just multiplying the two things together. And so if you're multiplying, does the order matter? No. So A dot B is the same thing as B dot A. Another one is that negative A dot B is the same thing as negative times A dot B. Which, again, this one should make sense. Because negative 3 times 4 is negative 12, and 3 times 4 times the negative is still negative 12. Another one, the same way that you have a negative out in the front, if you have some other constant times A dot B, is the same thing as K distributed to A dot B. And the last of the algebraic properties that's important to remember is A distributed. If you have a vector distributed to 2 other vectors, this is the same thing as A dot B plus A dot C. Because basically you're just distributing. Make sense?
Yep.
Cool. Good talk. Okay, so next page, page 10. I should have set a timer to end class. So this one is the vector equation of the line given in the direction through the given point. They give you the formula on your formula sheet for a vector equation of a line, which is R equals A plus TB. Sometimes they'll use, for the T, it could also be other symbols such as mu or lambda or anything else. T is just some constant that you're multiplying b by. So you're stretching that vector as long as you need to. So if I were to write the equation for this one, it would be r is equal to 4 -1 plus t times the vector 1, 4. So your A is your point. And your B is your directional vector. So for part question 2, it gives you 2 points. You can use either one of the points for your A, but you have to come up with your B, which is your directional vector. So in this case, my B vector would be equal to, and again, you can do this in either direction. I'll do 4 minus 1 is 3, and 1 minus 2 is -1. So if I were to write the equation, you could have r equals 4, 1 plus t times 3, -1. You could also have r equals 1, 2 plus t times 3, -1. And also, if you had done your points in a different direction, you could have had 4, 1 plus t times -3, 1, or 1, 2 plus t -3, 1. Any of those answers would be right.
Would they ever ask us to find t, or is that just?
Yes. When you're finding the equation, no. There are questions where they will ask you to find the value of k, or rather, more often they will ask you, they'll ask you whether or not, let me find one. They'll ask you where they intersect. They'll ask you determining whether, the question 3 on this page, determining whether or not the given point lies on the line. So what you do is you plug in the point for r. So I would have 0, 5, 9 is equal to 2, 1, 5 plus t times -1, 2, 2. And you solve it basically like 3 separate equations. So if I move this here to the other side, if I move my A to the other side, I would now have -2, 4, 4 is equal to t times -1, 2, 2. Is there a t value that is the same for every row that would make this true?
2.
Yeah, so if we made t 2, then we would get the other side, which means that yes, it would lie on the line. Now, say hypothetically that this had been the number 5 instead, then it would not lie on the line because the value for the first 2 would be 2, but 2 doesn't work for the last row, for the k row. Make sense?
Yeah.
Okay.
Well, actually, I have a question.
Okay.
K, what is K when you're talking about I, J, and K?
Mm-hmm.
Okay.
Yes. Okay, I'm skipping page 11 and we're going to do the last page, page 12. So for number 5, when I say distance, or when the question says find the distance between the points, what are you going to use?
The distance formula or the one where you like the square root or something?
Yeah, in vectors, it's the distance formula is called the magnitude. So for number 5, it's just asking you to find the magnitude. For 6AI, when they talk about unit vectors, it means that some value times some value times the vector that they give you, which in our case was 2, 2, 1. When it says the unit vector, it means some value, the unit vector times this would be equal to 1. So I can find this value by taking the magnitude. So it would be k is equal to 1 divided by the square root of 9, which is 2 squared plus 2 squared plus 1 squared is 9, which we know this is 1/3, which means that our unit vector would become 2/3, 2/3, and 1/3. I just multiplied 1/3 times this vector right here. And that's our unit vector. We good on unit vectors?
I think so, yeah.
So
All right, so the last one from this page that I want to do is 3AI. So this one, it wants you to determine whether or not they intersect. So an intersection is where they are equal. So what we're going to do is set the two equations equal to each other. And then I'm going to work row by row, basically. So we would have 6 plus 1 lambda is equal to 2 plus 2 mu. We would also have that 1 plus 2 lambda is equal to 1 minus 2 mu. And 2 plus lambda is equal to -4 plus 3 mu. So all I did was set the two equations equal to each other. And what this yields, if we were to continue to solve the equation, would be 4 plus 2, sorry, I lied. 4 is equal to 2 mu plus lambda.
Would it be 6 minus 1 lambda?
It totally is.
Okay.
I have plus negative on mine. I missed it. But this equation is right still, because you move the lambda to the other side. So it would be 4 is equal to 2 mu plus lambda. 0 is, 0 is equal to -2 mu minus 2 lambda. And then the last one would be 6 is equal to 3 mu minus lambda. And what we have here is a system of equations, but when we solve a system of equations with two unknowns, we're really we only need 2 of the equations, and the ones that I think are easiest to use are these 2, because one has a positive lambda and one has a negative lambda, which means that when I add them, I'll end up getting rid of the lambda. And so when I add them, I end up getting 10 is equal to 5 mu, which means that mu is equal to 2. And if mu is equal to 2, then both of those equations tell me that lambda should be equal to 0. In order to check whether or not these intersect, I need to verify that these 2 values satisfy this equation. So if I have -2 times 2, which would be -4, minus 0, I would get -4, which does not equal 0. Therefore, I can say that no, they don't intersect. Make sense?
Yes.
Okay. So I'm going to pause there and save the rest of the packet for Monday. But anything on these pages, you should be able to practice. I've also uploaded vectors onto Delta Math. But so that Delta Math is actually a separate classroom. I know that's sort of an inconvenience for you guys, but on Google Classroom, I posted a teacher code for you guys. But I'll send that out directly in an email in a couple seconds to make sure that you guys can sign in. All of that Delta Math is obviously optional. I have the topic 3 stuff, which is circles and trigonometry, and topic 4, which is vectors. So if you feel that beyond these packets, if you need additional help and you want to practice more, all of that stuff is there. Okay, does anybody have any other questions?
I have a question.
Go ahead, Madison.
So I got an extension on the probability packet. Should I just like turn that in when we have school?
Yes, you can do it on Google Classroom where it says topic 5, Delta Math and probability packet due. Just take pictures and submit them there. I would prefer that you use an app like Tiny Scanner, anything that converts your pictures to a PDF, just because they're easier to read.
Could you read mine? I tried my best.
I think so. I'm trying to remember.
Okay.
But yes. Any other questions? It's technically the end of class, but before I let you go.
Our IA is due this Sunday on Turnitin. Is that correct?
That's correct.
Cool.
Yep. All right. Have a great weekend.
You
too. Thanks, Ms. Thompson.
Bye.
Thompson.
What were you saying?